Tweed's Garage. In this video we'll be doing some more work on the Scott. Yes, a couple of bits to remanufacture on the Scott. They're sort of worn out and can't buy new ones, so we're going to make some new ones. So let's go and have a look. Let's go down to the bench. So welcome to what I currently call Scott's Corner at the moment. So continuing to work on the gearbox, sorting out all the bits and bobs. I think on the last video I said I couldn't find the link from the gearbox lever to the pedal adjuster, but I did find it. Yeah, it was in a box tucked away with Bantam stuff rather than Scott stuff. So yeah, managed to find it. This is it, and yeah, it's got a bit of wear to the point that somebody went to the trouble making these little brass collars to take some of the wear up on the pin there. But as you can see, like the proverbial stick in a top hat. Yeah, so I could sort of weld this up and re-drill it and all stuff like that, but I thought I'd yeah, put this to one side and just make a new one. So I've got a bit of square bar stock here to stick in the lathe and work out my process of operation for turning this up. So we need to drill a hole and tap it in the end there all the way through. We'll turn this, turn a taper on that, mill the square stock down to size at this end, mill a groove on the inside of it, and yeah, drill a nice snug fit hole for the pin to go through to hopefully take out some of the slack on the gear change movement. So that's one job to do. And then the other one was, if you remember back, taking the brake rod off, this back brake operating rod. It was truly looked like the dog had been chewing on it. I don't know what had been going on with this, but also it was a very loose fit and it waggled around quite a lot on the mountings that bolted to the frame. These items here. So yeah, if you pop that in there like that, it doesn't matter which way around it goes because it's so wobbly, and you can see there, look, it's yeah, there's loads of movement on there. They're not oval, I think they're sort of all over the shop. Can't really describe it, but anyway, so that one, and then that's the other side like that. And I think it should be 5/8, and if you get a 5/8 reamer, which I happen to have here, again you can see you know, just falls through it. So what I'm going to do, because the way these are worn, the holes are fairly round, but the sort of the side walls aren't very parallel to each other. They've got a bit of a sort of curve to them. So I think what I plan to do is set these up in the mill and you know, find the centre of the hole as best I can, and then go in with a small boring bar and the boring head and just sort of bore these out. I'm going to bore them out to 17mm. They're worn to about, varies where you go, but 16.3, 16.5, 16.6. This one's a bit, this must be the other side that doesn't get all the movement. Actually, this is a bit tighter, not so bad. That's about 16.1. Yeah, so I'll have to see what bar stock I can get, but I'll probably get a bit of 17mm bar. So leave that bit 17mm, then turn all these other bits down to the you know, the dimensions and lengths that they are there on this rod, and then hopefully that should sort of clear up some of that play on the rear brake. So two little jobs to do. Yeah, we'll get on and sort those out. So first thing to do was centre the square stock in the 4-jaw chuck. So just with a dial indicator on the corners, gradually went round and centralised the stock in the chuck. And then with that done, proceed to face the material off. Ready for me to then run a centre drill through. And then follow it on with a tapping drill for a 5/16 tap. And with the hole drilled down to depth, move that, change to a 5/16 BSF taper tap, and then ran that in on the lathe. And once it stopped, put on my tap handle and proceeded to tap the hole down as far as the tap would go. Alright. Right, I'll be in a minute, love. You all done, are you?
Yeah.
Right, I'll be in a sec. Stick the kettle on. Just got to tap this hole. And then it was just a case of moving from the taper tap to the intermediate and then finishing off with the plug tap to get the thread down the hole as far as I could. So with the holes tapped and drilled in the clevis, it was time to turn down the clevis down to its finished diameter on the nose of it. and then measured the angle and turned down the tapered nose on the end of it to match the original. And then just finished off by facing off the back of the clevis where it goes into the fork of it at a slight angle, mimicking the original. That was the majority of the turning work done, so moved the stock forwards in the chuck and then parted it off to length whilst it's still in the lathe. So with the turning done, we move over to the milling machine, and we're going to pop the job into the vise, and it's time for a bit of milling time.
Welcome to milling time. It's all yours and it's all mine.
No, milling time. So, like we do on round stock when I'm squaring it off, I'll explain it again for the likes of Jenkins and yes, Randall, you stroking your cat over there. So it's the same with square stock as it is with round stock when you're sort of taking multiple sides off, sort of, you know, equal amounts, working it out. So the first thing I need to do is find a parallel that would go in. This is the finished job. I've done it already, but I'm just going through it and showing you again how to do it. That when the job is down to size on all sides, it still has clearance above the jaws when we're machining the job. So this is the parallel that I used, like that. So that was the finished job. Well, yeah, that's the old one, but you know what I mean. So, and then this is the stock that we used for the job. So I'll just pop this off cut in just to sort of give you the idea of how we do it. So what I've done is, as we do with making nuts and stuff like that, we measure the outside diameter of the original material, which is 0.7835, and we want to get it down to this size. So we want to take the same amount off each side. So what we do is then we measure this, and that is 0.4980. And then we take one away from the other, and that gives us 0.2855. which is the complete amount we've got to take off the job to bring it down to size. But because we want to take even amounts off each size, we then divide that measurement by 2. That gives us 1.427. So that's the amount we take off each side. And what we do is, so you don't forget, you just write it with a Sharpie on your milling vise so you don't lose track of it. And then grip the job in the vise, bring the cutter down to the job and just till we get a witness mark, or you can do it with a piece of paper, you know, and then measure your paper and take that amount away so you know how much to lower it down till it's on 0. So with that touched off, if you then zero your reading on the knee, and then because it was 0.1427, I took 2 cuts at 50 thou. And then my final cut was 42.7 thou to give me my finished dimension. So with that done, release the job from the vise, turn it round to the next side, not opposite side, and then again we've got our reading on our knee, we know where our 0 point is, so we go back to 0 and then drop it down 50 thou and do our first cut, then our second, then our third, down to size. And then what we do is we leave the cutter where it is. So we leave it on our finishing cut. So that is our next 0 point. And what do I mean by that? Well, when we turn the job around to the next side, this has had 1.427 taken off the bottom side already. So and our cutter will touch this side. This will be 0 because it's the same distance where we finished off. So all you do then is 0 your reading on your knee handle, and then proceed again to take 250 thou cuts in your 42.7 thou, and that will give you your finished width with the equal amount taken off both sides. And then you just take it out the vise, move it round to the final side, pop the knee back to your 0 position, and then take your 3 cuts, and that will be finished down to dimension. I hope that makes sense. Randall. Then I had to think which way we were going to do this, but the easiest way was to mount it in the vise and with a wobbler find out the centre of the work and the end of the work, and that allowed me to pick up the hole position for the CLEVIS pin to go through. So I ran that through a centre drill and then slightly undersized drill. And to complete the hole, I just reamed it out to finished size, which was a 1/4 inch. So just pop the 1/4 inch reamer through. Then flip the CLEVIS pin 90 degrees in the chuck, squared it up again, then proceeded to centre drill and then drill out just undersides of the milling cutter as much material as possible. Before I went in then with a 1/2 inch milling cutter, gradually milling out the rest of the material to give me a nice square forked CLEVIS pin. As you can see, turned out quite nice. Matches the original, apart from the rounded back to the end of the fork on the inside of the clevis there rather than square, but it does make it a little bit stronger. And then I just marked out the ends, filed off most of the material and ran it through the belt sander to get my rounded edges on the end of the forks there to match the original. And then we just dropped it in some blacksmith's blacking, just a chemical black it to give it a bit of rust protection. And yeah, turned out nice again. So with the new clevis made, we'll pop it onto the gearbox. So screw it onto the selector. Pop the pin in. Washer and split pin. There we go. Gear selector mechanism back together. Now there's a bit of play on this I'm not happy with, where this hardened shouldered bolt has sort of worn its way into the backing plate. I don't know whether I can get rid of some of that somehow, but then I need to set this gear change mechanism up. So there you go, we've got gear selection, a 3-speed functioning gearbox. Yeah, I think it'll be better when the engine's turning it over, getting a bit of speed in there, and some oil in there as well will help a lot. So pretty much gearbox is nearly done. I have got to sort of take this plate off again and put a stop on here, stop the kickstart flopping forwards like that. Somebody said there should be a stop there, and there is evidence on the back of the plate that there was something there at some time. So just a little stop there to stop it flopping forwards and getting in the way. There you go. I think that's enough engineering for one video. So back to the idiot. So there you go, progress made on the Scott gearbox, and yeah, nice to have it nearly back together so we can get it bolted back into the bike, and then I'll be able to sort of kick the bike over and things like that. So a couple of little more jobs to do, like I said, try and sort this, get a bit of this play out of here. I don't think that helps the situation. Stop for the kickstart, yeah, and then I think that's ready to go back in again. Oh yeah, make up some bits, because we were going to do this reverse path for the clutch cable coming in from the back rather than the front. So I'll have a look at the clutch cable, make up some brass ferrules and stops to convert it so it comes in the other way. Yeah, so that'll keep you going. Didn't have time to show you the brake shaft, but you'll see that in the next video, like the part 2 of making Scott bits and bobs. So yeah, hope you liked the video. If you did, give us a little like and subscribe as usual, and yeah, I'll see you next time. All right, cheerio. Yeah, I've still got my chest, Jenkins. Video, we'll be making some more parts. Hello, welcome to Tweed's Garage. In this video, we're doing some more work. Got bogey at my nose. Hello, welcome to Tweed's Garage. We're in this Tweed sounds wrong. Dirty hanky.